Good morning, all of you. In the last period, we have studied about a very important identity, that is divergence and curl in electrostatics. And in previous lecture, we have studied about a Gauss Law statement and its differential and integral form we have already derived. Now, from this we have to derive what are the different application of Gauss Law. Now, first one is we have to consider a Gauss Law. It is used to find the electric field intensities. Electric field intensity for three applications. First one is a spherical symmetry, second one is a cylindrical symmetry, and third one is we have to consider the plane symmetry. In the today's lecture, we have studied about a spherical symmetry. Spherical symmetry. Already we have studied some application in the 12th standard, that is by using the Gauss law, that is total normal electric induction over a closed surface is equals to algebraic sum of the charges enclosed by that surface, and here we have to use the electric flux, that is surface integration of E bar dot dA bar is equals to Q enclosed divided by epsilon 0, or 1 upon epsilon 0 times total charge enclosed in that surface. And here also we have to study three applications. One more application for the spherical symmetry, second application for the cylindrical symmetry, and third application we have to consider for the plane symmetry. And we have to study three applications one by one. In the today's lecture, we have to find what is the electric field intensity of the spherical symmetry, and it has different types of cases we have to study in this article. The first one is we have to say that point is situated outside the what we have to consider that point P is situated outside the sphere. Secondly, we have to point P is situated on the sphere, and thirdly we have to consider the point P is situated inside the sphere. These are the three different types of cases we have to consider. First of all, we have to draw the diagram for this spherical symmetry, and after that we have to consider, that is what are the expression for that. Here we have to draw in the diagram. This is a sphere we have. Having charges, we have to say that at the center of that is considered as say Q, and after that we have to say that the radius of the sphere is considered as say capital R, and here this is we have to draw the Gaussian sphere or Gaussian surface. And for that Gaussian surface, we have to consider any point say P. Here we have a small element that is considered as say at a point is considered as say point is what we have to say that P, and this distance is we have to consider here, this is a small r, and here we have to find the electric field intensity, that is what we have to say that E bar, and ds is considered as what we have to say that a ds is nothing but we have to consider the small element ds, and at point say O be the center of the charge is what plus Q, and O is the center of the circle, or it is what we have to consider here O. Right. Let R be the radius of sphere, and Q be the charge Q will be the charge at point O. Q will be the charge at point O. This is what we have to consider for the sphere. And after that, number one case we have point P situated outside the sphere. Case number one. Point P is situated outside the sphere. Here we have to say that sphere is this one, and here point P is situated, what we have to say that, outside the sphere. And so condition is what? That is small r is very greater than capital R. This is the case. Small r is greater than the capital R. And for that we have to consider P be any point at a distance r from the Gaussian. This is considered as what? Gaussian surface. Let point P is situated at a distance small r. Point P is situated at a distance small r from the center of sphere. From the center of sphere, and draw center of sphere, and after that we have to say that draw a spherical surface called as, that spherical surface is called as what? A Gaussian surface. Gaussian surface. This is the point we have to consider here. Now, while we have to explaining the application of Gauss law, many times question is asked on that for 10 marks. Obtain an expression for electric field intensity of a spherical symmetry at a point which is situated outside the sphere. 3 cases. It may be discuss different types of cases also, but here the first case is what? Point P is situated outside the sphere. After that, we have to know the Gauss law. That is, according to the Gauss law, we have to say that, what is Gauss law? According to Gauss law, that is surface integration of E bar dot dA bar over the surface S is equals to 1 upon epsilon naught into a total charge, and total charge is nothing but what? We have to say that Q enclosed, and nothing but Q enclosed is nothing but what? We have to say that, that is equals to, we have to say that Q upon epsilon naught. This is the first equation we have to consider for the Gauss law, and therefore electric field is a constant we have to consider here, that is E bar into surface integration of dA over the surface S is equals to what? Q upon epsilon 0. Now we have to know what is the area of sphere. that is 4 pi r square. Means what we have? What is the surface integration of sphere? We have to consider here, that is dA bar is equals to a 4 pi, and it gets that is E into magnitude of E bar is what? E, and into the surface integration of dA bar is what? 4 pi into r square into q by epsilon naught. And finally we have to get that is electric field intensity E bar is equals to, we have to write here, that is electric field intensity E bar in the vector form. We have to write here, that is E bar is equals to 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught into q by r square into r cap. And this is the first formula for the electric field intensity. E bar is equals to 1 upon 4 pi epsilon 0 q upon r square into r cap. This is a very popular formula for the electric field intensity for the spherical symmetry. And after that we have to say that is the field outside the surface is exactly same at it would be been if all the charge had been conducted at the center. If all the charge is conducted at the center, and at that time we have to say that electric field is similar, that is E is equals to 1 upon 4 pi epsilon 0 q upon r square into r cap. This is the, we have to say that electric field intensity. If the charge density is what is the charge density we have to consider here? Now, charge density is rho, and rho is equals to nothing but what we have to say that charge per unit volume, and the charge is considered as denoted by what symbol is here? Q. And what is the volume of sphere? Volume of sphere is 4 by 3 pi r cube. Means we have to say that 4 by 3 pi r cube. This is the volume of sphere we have to consider, and that is a total charge density is always remains a constant over the whole sphere, and this can be put in equation number say 1. What you have to get that value of charge is equals to, therefore Q is equals to 4 by 3 pi r cube into rho. Put in equation 1. We have to substitute this value in equation 1. It gets that electric field intensity, we have to write that E is equals to 1 upon 4 pi epsilon naught. E is equals to 1 upon 4 pi epsilon naught into what is the value of Q? Q is 4 pi r cube into rho divided by 3. This divided by r square. This divided by r square into, we have to say that is in magnitude. That's why we have to don't write the cap. And finally we have to get 4 pi is cancelled with what? This 4 pi is cancelled with this 4 pi. And after that we have to write that electric field intensity E is equals to here we have rho into r cube divided by 3 into epsilon naught into r square. This is the formula for electric field intensity we have to derive here. That is E is equals to rho into r cube divided by 3 epsilon 0 into r square. This is equation number say 2. And this is called as electric field intensity of a point situated outside the sphere. outside the sphere. This is the first case. And after that we have to second case, that is case number 2. Case number 2. First case is what? Point P is situated outside the sphere. म्हणजे या ठिकाणी आपल्याला outside the sphere वरती पॉइंट होता. Now point P is situated on the sphere of the surface. On the sphere of surface, that is small r is equals to capital R. Small r is equals to capital R. Again we have to say that let P be any point at a distance r is equals to small r is equals to capital R. Means we have this point it comes here. Both the points are at the boundary. Small r is and capital R are similar. At that time again we have to derive the electric field intensity according to Gauss law. What is Gauss law? Surface integration of E bar dot dA bar is equals to Q upon epsilon naught. This is, and this is what we have to consider the equation number say third. Again we have, that is magnitude of E bar into surface integration of dA is equals to, over the surface is what we have to say that S is equals to Q upon epsilon naught. What is magnitude of E bar? That is E into, what is the surface integration now? Now capital R and small r are similar. So we have to say that surface integration is 4 pi into, not small r square here, capital R square. Because both are similar, into Q by epsilon naught. And finally it gets that E is equals to 1 upon 4 pi, and this is what? Epsilon naught into Q divided by R square. This is the electric field intensity we have to consider here. And while we have to write the electric form, therefore in vector form, we have to write that E bar is equals to 1 upon 4 pi epsilon naught into Q by capital R square into R cap. This R cap here, that is, we have to consider the unit vector, it is in the direction of the electric field intensity. And this is expression for electric field intensity. This is electric field intensity. This is electric field intensity at a point situated on the surface. That is, small r is equals to capital R. This is the very important expression we have to study here. That is, derive an expression for application of Gauss law. That is, first one is what? Spherical symmetry. And for the spherical symmetry, we have a 3 number of cases. The first case we have to study, that is, point P is situated outside Point P is situated outside the spherical surface. So small r is greater than capital R. And let the point P is situated at a distance is what? Small r from the origin of the charge. That is what we have to say, that plus q. And then we have to draw a spherical surface. This is called a spherical surface. And that spherical surface is also called as a Gaussian surface. This is called as what? A Gaussian surface. Gaussian surface is here. Dotted surface is considered as a Gaussian surface. And for the Gaussian surface, we have to consider, or we have to apply here a Gauss law. According to the Gauss law, we have to remember, this is very important for all the application. That is the surface integration of E bar dot dA bar is equals to Q upon epsilon naught. And here we have to say that surface integration of E bar dot dA bar is equals to 1 upon epsilon 0 times the total charge enclosed in that surface, that is Q enclosed. And here we have to say that Q enclosed is nothing but what we have, that is plus Q. Plus Q is the charge situated in that surface. And after that, we have to use this one, that is taking E bar is the electric field is the constant for that surface, that is magnitude of E bar into surface integration of dA is equals to Q upon epsilon 0. Surface integration of dA is nothing but 4 pi r square, and that is equals to what we have to say, that Q upon epsilon 0. And surface integration of spherical surface is 4 pi r square. Here if we have to consider a vector form. In vector form we have to say that vector notation, we have to say this is vector form, that is E bar is equals to 1 upon 4 pi epsilon 0. This is E bar is equals to 1 upon 4 pi epsilon 0 Q upon r square into r cap, equation number 1. And this is electric field intensity, that is in terms of what we have to say, that small r. But in terms of surface charge density, sometimes question may be asked on that. And at that time the charge density is nothing but Q upon 4 by 3 pi r star Q. And Q is nothing but what we have, that is multiply here, that is rho into 4 by 3 pi r cube into rho. This is the charge. Substitute this value in equation number 1 here in the form of what we have to say, that Q च्या ठिकाणी आपण ती व्हॅल्यू टाकणार आहोत. And it gets that 1 upon 4 pi epsilon 0 as it is. What is the value of Q is nothing but 4 pi r cube into rho divided by 3. It is divided by r square. We have to don't write r cap because it takes in magnitude. Therefore E is equals to rho into r cube divided by 3 epsilon 0 into r square. This is the one of the formula for the electric field intensity in terms of surface charge density. In terms of surface charge density, and that is we have to obtain the charge density, and that is at a point outside the spherical field. And after that we have to study the case number 2, when the point P is situated on the boundary. At that time small r is equals to what? Capital R. We have to get the one more formula. Again only replace what we have, small r by capital R, because small r and capital R similar. So we have to explain here, let P be any point at a distance is small r is equals to capital R. According to again similar that what we have to say, that Gauss law is equal to surface integration of E bar dot dA bar is equals to Q upon epsilon 0. Magnitude of E bar is what we have to say, that E. Surface integration of dA, we have to consider the inner surface here, that is whole surface we have, small r is equals to capital R. So 4 pi r square is equals to Q upon epsilon 0. And finally it gets that E is equals to 1 upon 4 pi epsilon 0 Q upon capital R square, or we have to write the small r square, because what we have to say, that small r is comes into inside on the surface. And that's why, that is we have to consider the diagram is like that, that is small r and capital R are the similar. So all the points are on the same boundary. So this is considered as what? Capital R. And that's why, that is we have to consider the expression for electric field intensity. Write down all the points are very important. Again we have one more important case, that is third case. First one is outside, second one is boundary, and third one is inside. These points we have to firstly write down, and after that we have to consider the third case. Now case number 3. सर्वांनी व्यवस्थित लिहून घ्या. Case number 3. For that we have to rough this portion here. Case number 3. Point P is inside the solid sphere. Point P is inside the solid, inside the solid sphere. Solid sphere, that is small r is less than capital R. This is the case number 3. Point P is situated, small r is less than capital R. Now draw the figure first of all here. Again we have to consider here, this is a sphere and we have to consider here inner sphere. Point P this is a Gaussian sphere. Here we have to consider charge. A radius is, say, this is capital R, and now point P is charges, we have to consider, say, Q dash, and this is what we have to say, that point is what? R, and here we have to find the electric field intensity. This is the picture, that is small r and capital R, and O is considered as what? A center of the sphere. Right, this is considered as a Gaussian surface. Gaussian surface. Let point P is situated inside the sphere of a radius small r. Point P is situated at a distance. Point P is situated inside the sphere of radius is considered as a small r, and all other construction is similar. Capital R is considered as what? A radius of the sphere, and Q dash should be the charge. Q dash be the charge at point O. Okay, according to the Gauss law, what is the statement of Gauss law? Again we have to say that surface integration of E bar dot dA bar over the surface S is equals to what? Q upon epsilon naught. This is the first equation we have to consider. Equation 2, this is 3, this one is equation number, say, 4, and again we have to consider this is the surface integration of E bar dot dA bar is equals to Q upon epsilon 0. Again we have to take the E bar is the constant, so that we have magnitude of E bar into surface integration of dA bar is equals to dA is equals to q upon epsilon naught, and this is nothing but what? Magnitude of E bar is E. Magnitude of E bar is considered as E into surface integration of dA. dA is what we have to consider, say, area of the sphere, and area of which sphere we have to consider here? Inner sphere. This is 4 pi into r square is equals to q by epsilon naught is equals to q by epsilon naught, and finally it gets that is surface integration is equals to 4 pi r square into q dot. This is equation number, say, 5, and after that we have to consider a charge density. As the surface is a uniformly charged, charge density rho is given by as surface is uniformly charged, therefore charge density rho is given by, charge densities we have to consider here, rho is considered as the charge density, and it is given by, what is the rho now? Rho is equals to, that is q dash. Now what is the charge here? Q dash upon volume is what? 4 by 3 pi archa cube. 4 by 3 pi archa cube. This is the charge, and after that again one more we have to consider, that q dash is equals to 4 by 3 pi archa cube into q dash, into rho, right. Put this value in equation number 5. Put in equation 5, what you have to get, that E is as it is, E into 4 pi archa square is equals to 1 upon epsilon 0 is as it is into 4 by 3 pi archa cube into rho. Now what factors are cancelled here? Let us see here. 4 pi is cancelled with 4 pi. R square is cancelled with this r cube. And remaining factors are E is equals to, here we have to remember, small r into rho divided by 3 epsilon 0. This is, again we have electric field intensity in terms of surface charge density, and again or rho is equals to what? Q by, first article we have to say that rho is equals to Q by, what is the formula? 4 by 3 pi archa cube, or Q dash is equals to what? 4 by 3 pi r small cube, right? Both are Q now. We have to find the value of Q. Both the surface charge density are similar. So we have to consider, say, Q is equals to what? We have to cancel this factor 4 by 3 pi, and r cube is a constant here. 4 by 3 pi is cancelled with this 4 by 3, and again we have, this is what we have, r cube into q dash divided by r cube, or q is equals to r upon small r whole cube is equals to Q dash. Now substitute this value in equation number what we have to consider here. This is a Q dash, equation 5. Put in equation 5, what you have to get that? E is equals to E into 4 pi R square is equals to what is Q dash? That is R upon small r, so Q into Q dash, right? We have to find the Q dash. Okay, Q dash find करायचं तो उलट होईल ते. That is, we have to find the value for Q dash. Here we have to write the Q dash is equals to small r वर जाईल आणि capital R खाली येईल. चा Q into Q. This is Q dash. Put this in equation 5 and 5 becomes what? 5 is here. Q dash is what? Small r upon capital R. चा काय होईल या ठिकाणी? Q into here Q. This divided by is nothing but what? Epsilon 0. And finally we have to consider that is a electric field intensity. What is electric field intensity? Here constant factor is what? R square is cancelled with this R, and it means that E is equals to, here one step is we have to increase 4 pi, and here what we have? R into Q divided by R into Q divided by capital R into epsilon naught, and finally capital R Q capital R Q into epsilon naught, and finally it gives that E is equals to we have to write that is 4 pi and epsilon, that is 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught into, here we have R into R cube, and it gets that finally Q into R, we have to directly write here Q into R, and this is what? 4 pi into epsilon 0 into R ka cube. This is one more formula. Sometimes question may be asked on this type. E is equals to Q of R divided by 4 pi epsilon 0 QR upon R cube. Or we have to write that 1 upon epsilon 0. This can be written as also E is equals to 1 upon 4 pi. If E is equals to 1 upon 4 pi epsilon 0 Q into R divided by R cha cube. This is the electric field intensity we have to asking in the exam. That is 3 different number of cases we have to study for this article. That is spherical symmetry. First one is point is situated in outside the sphere. Second one is on the sphere. And third one is what? Inside. म्हणजे पहिल्यांदा कुठे होता? Outside ला. नंतर boundary वरती. आणि नंतर what we have to consider? That is inside. Let P be any point situated at inside the spherical shell and having radius is say R, Q dash is the charge at a point is say O. According to the Gauss law, we have to say that electric field intensity, that is surface integration of E bar dot dA bar is equals to Q dash upon epsilon 0, and then again magnitude of E bar is the constant, dA bar is integration 4 pi r square, Q dash divided by epsilon 0, equation 5, as the surface is uniformly charged, and then we have to say that charge density is given by charge per unit volume. Volume of the sphere is 4 by 3 pi r cube. So Q dash is equals to 4 by 3 pi r cube into rho. And put in equation number 5, it gets that E into 4 pi r square into Q dash is 4 by 3 pi r cube into rho divided by epsilon 0. 4 pi r cancel. And again this is what? This is expression for electric filled at a point inside the charge sphere. This is one more equation that is considered as equation number 6. Or this can be written in that type. That is, we have to know that basically charge density on the sphere inside and outside, that is q upon 4 pi r cube, and here q dash upon 4 by 3 pi r cube. 4 by 3 pi is get cancelled. That is, we have to get that q is equals to r cube in numerator, and denominator is small r cube into q dash, and from this we have to find what? Q dash, and q dash is equals to this r comes here, r upon r whole cube into q. Put this in equation again, 5. It gives that E is equals to qr upon 4 pi epsilon 0 into r cube. This is again electric field intensity at a point which is situated inside the charge sphere. This is very important article. Many times question will be asked on that. For 10 mark, derive an expression for electric field intensity of a spherical symmetry when the point is situated outside, on the boundary, and inside. This is very important. Write down all the points. I think we have to understand very well. This is very important question because in this topic 3 application and 3 questions may be asking on that for 10 marks, and due to that out of 3 1 may be every time asked in the exam. That's why this is very important for studying this topic. Okay, understand. Thank you. Write down.